The famous WannaCry ransomware used Eternal Blue exploit for the initial compromise. Eternal Blue exploits vulnerability in Microsoft Windows SMB v1 service running on a remote machine. The CVE number for this vulnerability is CVE-2017-0144. In this video, I will be recreating the scanner to find if the target machine is vulnerable to CVE-2017-0144. I have a very simple lab setup here. So Kali Linux as an attacker machine, Windows 7 as a target machine. Windows 7 will be running a vulnerable version of SMB v1 service. I have a network capture from a Metasploit. Let's open this. Yeah, as I was speaking, there is a scanner which runs before the actual exploit, and these are the packets triggered from this scanner. There are four major protocols of requests which are sent to the target machine. The negotiation of the protocol, setup of the session, tree connect, and a peak name pipe. So in negotiation of the protocol, we are negotiating with the server if server speaks SMV v1. Then there is a session setup. We are basically doing an anonymous login and nothing fancy about it. And then we are doing a tree connect. The tree in SMB are like directories. So we are connecting to a directory on this host. The name of directory is IPC. So IPC dollar is a special hidden share, and it's mostly available on the SMB servers. It's inter-process communication. So using this share, we can read, write, or peek a pipe on the server. After we have established a tree connection or a when this tree connection is successful, we do a transaction request. This peak name pipe request you are seeing, this is a transaction request, and based on the response of this request, the scanner decides if the server is vulnerable or not. We are seeing a status insufficient server resources. That means server is vulnerable in this case. Let's also see an example where SMVV1 is enabled but it is not vulnerable. Then in that case, you will see all the packets are similar except the response from the server to this peak named request. I ran the same scanner against Windows 10 while enabling the SMB1 protocol. So you can see negotiation protocol, then there's a session setup, then tree connect, and a peak name pipe request. The response to this request is status access denied. This server is patched. That's why we are seeing this kind of response here. Let me go back to the Windows 7 SMV1 server response. So it mentioned status insufficient server resources. While studying this network traffic, I found there is no special crafting or nothing is being changed in these packets. The negotiation protocol, session setup, and the tree connect. Only the special packet which is sent from the scanner is peak named pipe request. So we'll try to recreate and we'll try to resend these packets from our script and see how it works. So I'll be running the scanner against Windows 7 target, and we'll capture the traffic. Yeah, let's just okay. Let me take this to the third screen. It's 56.101 tunnel blue scanner, and we'll give arguments. If we run this, run it as it is, so it will ask IP and port. IP is 192.168.56.101 with port is 445. And before running the scanner, I need to identify which interface I need to capture the traffic. So this is the host Ethernet IP 192.168.56.102 at ETH1. So we'll do the capturing at ETH1. I am applying a capture filter. Yeah, now it's set up. This is the IP of Windows 7 machine. Let's run this, and in background you can see few of the packets are captured, and in the output you can see IP. This is the IP and port is open. SMB dialect is this. OS is this. Error class is 5, which means it's vulnerable, and it says 101 is vulnerable to MS17. So MS17 is a patch applied to this vulnerability. Ideally, this line should be 101 is vulnerable to eternal blue or maybe CVE-2017-0144. Okay, so let's see the capture. It's it's exactly the same way like which we saw earlier, which was generated through this Metasploit auxiliary scanner. So there is a negotiation protocol response. You can see in response there is a this is the selected index or SMV1 is selected from like accepted by the server. Then there's a session setup. Then there's a tree connect and a peak name pipe request for this particular pipe. Okay, so let's check the script how it works and what it actually implements. So in the script, this is the argument handling part. Then the very first thing the script does it to check if the port is open, the 4445 port is open. I'm doing this in two ways. If the script is running as root, it will do a half scan known as sin stealth scan, and if it is not open, it will do a complete full packet scan. Yep. So after we have identified if the port is open, we'll initiate this function. We'll run this function check SMB vulnerability. So this function exactly sends those four packets which we just saw in the Wireshark. This single line itself does that negotiation protocol and the session setup. I'm using impacket SMB library for SMBv1 packet crafting. Then it does the tree connect, and that's how those tree connect request and response packets you are seeing. In return, it returns a TID. Here is the interesting part. This is the part where we are creating that transaction packet with subtype with subcommand as peak named pipe. So in transaction packet we are first creating a SMB packet, then we are creating a transaction command. In transaction command we have to set two things, parameters and data. So these are all the things which needs to be set in the parameters. So to do this, what I tried, like I check that this actual request which was sent by the Metasploit, and whatever parameters I was seeing here, I just tried to replicate those. So you can see a maximum value here, null value here, and the peak named pipe which we are peaking is named as pipe. You can name it anything. So the main thing you have to remember is the pipe should not exist actually. So that's why you will see that error saying insufficient server resources. So I'll be uploading this script. You can have a closer look and try to understand the script, or maybe modify or make it better. Once this packet is created, we'll send it to SMB and receive the response based on the error class of the response. If it is 0x5, we will identify if this server is vulnerable or not. So that's how auxiliary scanner did it, and I replicated it.